Newton's method is famous for finding roots quickly, but with one simple function, it can bounce forever between 0 and 1. Let us watch every step happen. Here is the function. We want an x value where the curve reaches height 0. That x value is called a root. Newton's rule says, take the current guess, subtract the curve's height divided by its slope. The result becomes the next guess. In plain language, measure the height, measure the slope, then follow the tangent line until it reaches height 0. We will keep those moves separate. Start with x0 equal to 0. This is only our first guess. The curve itself sits 2 units above the axis there. First, measure the height. Substituting 0 gives 2. So the point on the curve is 0, 2. Differentiate the function. The slope is 3x squared minus 2. At 0, the slope is minus 2. The tangent through 0, 2 with slope minus 2 is y equals 2 minus 2x. The correlline is our local straight line guess for the curve. Now ask where that tangent reaches height 0. Solving 0 equals 2 minus 2x gives x equals 1. So 1 becomes the next guess. The first Newton step sends 0 to 1. So far, nothing looks strange. Now repeat exactly the same 3 moves at 1. At 1, the function value is 1 minus 2 plus 2, which equals 1. The curve is still above the axis. The slope at 1 is 3 minus 2, which equals 1. This time the tangent points upward. The line through 1, 1 with slope 1 is simply y equals x. Again, use the choral tangent as the local straight line guess. Where does y equals x reach height 0? At x equals 0. The second Newton step sends us straight back to the starting guess. Now the trap is visible. 0 sends us to 1, and 1 sends us back to 0. The 2 tangent steps undo each other. Nothing changes on the next round. From 0, we get 1 again, then 0 again. The method bounces forever and never reaches the actual root. The reason is simple. A tangent line only copies the curve near the current point. If we follow it too far, the real curve may bend in a very different direction. The actual real root is about minus 1.769 on the left, but our tangent hops stay trapped at 0 and 1 on the other side. We can prove this is exact, not a drawing accident. Call one complete Newton step n of x. Substituting our function gives this formula. At 0, Newton's formula gives 0 minus 2 over minus 2, which is 1. At 1, it gives 1 minus 1 over 1, which is 0. These are exact whole numbers. So rounding is not the cause. Even with perfect arithmetic, this starting guess produces the same loop forever. A different starting guess can behave completely differently. Starting at minus 2 gives minus 1.8, then minus 1.7699, and quickly approaches the root. There is also a safer clue. This function is a polynomial, so it is continuous on the interval from minus 2 to minus 1. Its values there are minus 2 and positive 3. By the intermediate value theorem, a root lies in that interval, and bisection can keep narrowing the bracket. The practical lesson is to watch the guesses. If they repeat or stop improving, do not keep running blindly. Change the start, or switch to a bracketed method. Newton follows tangent lines, and tangent hops can form an exact loop. Here, 0 and 1 bounce forever.